Okay, we're in Project O, still Math 120, Math 121. I believe this is the last project in the series. More projects may be added later on as faculty members catch on to how important it is to work a computer algebra system. They may request more projects to be put onto this, all right? I'm hoping you're having a good time working through this stuff over here and learning stuff as you go along. So, over here it says use Sage to find the approximate surface area of a solid generated. And this is something you learn in Math 122. And they give you this function over here, y is a function of x, on the interval between 0 and 3. Now, I do mention in the past I was a big fan of the TI-89 calculator, and this was a remarkable tool when it first came out because it was handheld, and you could do some pretty impressive stuff with the TI-89, but it really impressive. But I think as times went on, sort of like the cell phones started to take over, and cell phones became the default calculator for most students. All right, and the cell phones can also run Sage, by the way. Some people's cell phones are incredibly powerful, right? They can run a lot of applications, good memory, good cameras. They got a lot of stuff going for them, good screens, whatever. Okay, so over here, I just want to point out, you should be able to set the integral up and be able to do the integration over here. So that's all this stuff is over here. It's a numerical integral problem. I want to point out, though, and let me get to that in a second. Let me clear the screen. I'll type in reset. X is a variable. I'm pretty good at that now, right? At least I learned that much so far. And I don't know, I'm getting lazy. I'll just do this over here. That's the function. And what's the function? Y is a function of x. It equals the Euler's number raised to the minus x squared over 2. I'm going to put FP down, which is a derivative. Right? It's the derivative, f prime. That's what that stands for. And what's that derivative? DIFF of f of x. I'm actually going to type it in, f of x with respect to x. All right, worked out pretty nicely, by the way. Now, by the way, I'm not going to use numerical integral. I want to show you what happens. I'm going to integrate. And what am I going to integrate? I'm going to integrate this. 2 star pi star f of x star, I'm using to get this integral, I'm using the formula that I was taught in Math 122. And that's going to be, let's see if we can put this down, square root, and it's going to be, let's write this down, 1 plus f p of x, that whole thing squared. I'm going to close out the root function now. And I am going to say this integral is with respect to the letter x. And I'm going to go between 0 and 3. And let's hope I didn't make any errors. All right. And by the way, it's remarkable. It did it. All right. I really mean that. It's remarkable. It did a great job. All right. Now I'm looking at this thing and I see there's all kinds of things I don't understand though. And what I mean by that, error functions have not been introduced at this level. But what I want to do, that's ERF by the way, I want to see if I can approximate it with a number. Now I want to point out what the underscore means. It means the prior output, the dot n, adds an abbreviation for numerical approximation. And I want to see what happens. And what do we get? We get the number 9.36. And I'm wondering, did I make a mistake somewhere? 2 pi f of x. I did. I made a mistake in my integration. Let me go back to my integration. I forgot to type in the square root. And let me do that. Oh, it's working. Let's see if it's going to do it though. By the way, I'm going to put another terminal window. I can run the top application to show you something. Oops, right there. All right, this still has not put output. I want to put out, by the way, this is, it's an M1 processor, multiple cores. One of the, by the way, my machine is at it's 70, it's almost 80% idle, but one of the cores is saturated. It's absolutely saturated with the processing. It's Python code. So it's doing something. I don't know what it's doing, but it's working on something. One of the cores is completely saturated. I mean, it's almost 100%. Let me go to my process viewer. I'll show you that. And I want to show you let's see how many cores I got. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, one of the cores is really working hard, isn't it? You can actually see it here, right? One of the cores working really hard, right? Really hard. Let's get back. And it's still working. Now, someone says, could you kill it? I'm going to kill it now by doing Control-C, right? So I interrupted the process. And what I want to do is, I want to do numerical approximation instead, all right, numerical integral. But the reason for that is it's going to force it to do a computation, all right? So the integrate, it did seem like it was going to be able to do it. It was processing. I'm not sure what it was doing, but it was doing something. It must have been a tough integral to do, by the way, all right? What are you going to do over here? Do the numerical integral. You get a number. The number's going to be the same thing my TI spit back, by the way. By the way, approximately 8.565, all right? Thank you so much for paying attention, though. I do appreciate it.